At 14:45 local time on June 27, 2025, a Ukrainian MiG-29 from the 40th Tactical Aviation Brigade banked hard left as voltage warning screamed across its weapons interface. The mission to strike deep into Russian territory had been smooth until this moment. Everything was about to change in seconds. His radar warning receiver suddenly erupted as an S-300 acquisition radar locked onto him from 95 kilometers away. The pilot immediately dove to 500 feet, using the terrain to mask his approach while the weapon systems ran their startup sequences. Each GBU-39 precision-guided bomb needed to acquire GPS locks, calibrate its inertial navigation system, and verify communication with the improvised interface. The process should take 30 seconds. It had already been 2 minutes. At 14:48, all 4 bombs finally showed green. The iPad mounted in the cockpit displayed the target coordinates. A drone manufacturing facility 350 kilometers inside occupied territory that produced 40 Shahed 136 kamikaze drones every single week. Intelligence reported a Krasuka-4 electronic warfare vehicle protecting the site, pumping out 500 watts of GPS jamming. The pilot checked his fuel, 2,100 kilometers remaining. After weapons release, he'd have exactly 18 minutes over hostile territory before bingo fuel forced him home. The S-300 radar intensified its scan pattern, now joined by an SA-15 system sweeping from the southeast. In 6 minutes, he'd have to climb to 15,000 feet for weapons release, exposing himself to every air defense system in the sector. The GBU-39s could glide 110 kilometers from that altitude, but their guidance systems had to survive the climb through electromagnetic interference that would fry most commercial electronics. Suddenly, a voltage spike hit 31 volts for 3 seconds before the regulator caught it. The adapter pylons holding the bombs were pulling 32 amps through circuits designed for 20. Somewhere in the maze of improvised wiring, Ukrainian battlefield engineering was fighting Soviet electrical standards for control of American weapons. The pilot pushed the throttles forward. Twin RD-33 engines responded with 18,300 pounds of thrust each as he crossed into the contested zone at 14:51. Every threat receiver lit up simultaneously. S-400 radars from Mariupol, mobile SA-15s vectoring to intercept, and the first traces of Krasuka jamming bleeding across GPS frequencies. In 19 minutes, he would discover if 4 precision weapons held to Soviet wings by salvaged tank parts could survive the most sophisticated air defense network outside of Moscow. At 15:15 local time, the pilot banked right into an 8-kilometer gap between overlapping S-300 coverage zones. The route Ukrainian intelligence had plotted required flying between ridge lines for the next 7 minutes, using terrain masking to stay below the radar horizon while creeping closer to the target. One navigation mistake would put him squarely in an SA-15's engagement envelope. The gap existed because of simple physics. The S-400 near Mariupol couldn't see below 800 feet at this range due to Earth's curvature. The S-300 batteries had their radars positioned to defend against high-altitude threats, creating dead zones at extremely low level. But this corridor demanded precise flying. Drift just 2 kilometers left and the Western S-300 would acquire him. 3 kilometers right meant death from an SA-15 patrol route. At 15:18, the pilot's radar warning receiver showed new activity. A mobile SA-15 had stopped moving, its operators likely suspicious of the gap in their coverage. They began radiating with their search radar, probing for exactly what the pilot was doing, exploiting the weakness in their deployment. He pushed lower, now just 400 feet above a dry riverbed, his fuselage barely clearing power lines that hadn't appeared on mission planning imagery. At 15:22, the pilot initiated a 4G climb to 15,000 feet. His radar warning receiver immediately lit up as multiple fire control radars achieved lock. The S-400's gravestone radar burned through Ukrainian jamming with 350 watts of power, painting the MiG with enough electromagnetic energy to physically heat its radome. The pilot had exactly 90 seconds to reach the launch point before entering the S-400's engagement envelope, where missiles could reach him in 24 seconds. The timing was critical. Ukrainian Su-24s had launched a HARM anti-radiation missile attack against radars near Tokmak 45 minutes earlier, forcing them offline temporarily. Electronic warfare units broadcast false radar returns showing a strike package approaching from the northwest. These decoys drew defensive attention while the lone MiG approached from an unexpected vector. Every element of the mission had been choreographed to create this 90-second window of opportunity. As he leveled at release altitude, the pilot's instruments showed 12 minutes of fuel remaining for the return flight. The GBU-39s ran final system checks, their GPS receivers tracking 5 satellites with position accuracy of 3 meters. Target coordinates were locked and loaded. The pilot checked his tactical display one final time. The nearest SA-15 battery was 41 kilometers southwest, outside its engagement range, but close enough to react if he lingered. S-400 radar emissions indicated the battery was preparing to fire, but physics dictated their missiles would arrive 30 seconds after weapons release. The Krasuka-4 electronic warfare vehicle near the target had been transmitting GPS jamming signals for the last 10 minutes, flooding frequencies with 500 watts of interference. The Russians were blasting noise into GPS signals, trying to blind any aircraft depending on satellite navigation. But none of that mattered. In 60 seconds, he would discover whether American engineers had truly designed the GBU-39 to operate in the most hostile electronic environment on Earth. The fate of Ukrainian civilians depending on stopping these drone attacks rested on 37 kilograms of explosive and the electronics that would guide them through the invisible storm ahead. At 15:28 local time, the pilot pickled the first GBU-39. The aircraft lurched upward as 250 pounds separated from the starboard pylon. Its GPS receiver immediately detected massive interference across all channels. Within 200 milliseconds, the bomb's guidance computer registered signal-to-noise ratios below acceptable thresholds and seamlessly transitioned to inertial navigation mode. The Krasuka-4's operators, 82 kilometers away, had no indication their jamming had just defeated itself. 6 seconds later, he released the second weapon from the port pylon, then the third from centerline, then the fourth. Each bomb deployed its wings at precisely 2.7 seconds after release, transforming from ballistic projectiles into guided gliders capable of 20-to-1 lift-to-drag ratios. Their onboard computers calculated optimal flight paths to converge on the target from different angles, ensuring no point defense system could engage all 4 simultaneously. The weapons would fly 89 kilometers through contested airspace, arriving at 30-second intervals to maximize destruction through sequential detonations. The pilot immediately rolled inverted and pulled 5Gs toward the ground. His radar warning receiver showed SA-15 acquisition radars transitioning to tracking mode as their operators finally realized what was happening. The nearest battery launched 2 missiles at 15:29 and 15, but their intercept calculations showed arrival 45 seconds after the MiG would disappear behind terrain masking. Physics and geometry had already determined the outcome. Meanwhile, the GBU-39s flew their programmed routes at 180 meters per second. Each bomb's computer performed navigation updates 20 times per second, comparing accelerometer data with pre-programmed waypoints stored in hardened memory. When GPS signals briefly penetrated the jamming at 15:31, the weapons updated their positions and confirmed they remained within 8 meters of their intended flight paths. The inertial navigation had maintained sufficient accuracy despite flying through the most intense electronic warfare environment in the world. The first bomb acquired its target at 15:32:44, using its uncooled infrared seeker. The assembly building's metal roof radiated heat differently than surrounding structures, creating a thermal signature the bomb's algorithm matched against reference imagery with 94% confidence. The weapon adjusted its terminal trajectory using tailfin, movements calculated to impact at a 68-degree angle for maximum penetration. The second weapon struck the electronics workshop 28 seconds later. This building housed the guidance system programming stations where Iranian-designed autopilots were configured for specific targets. Without this capability, completed drones became expensive model airplanes incapable of precision strikes. The bomb penetrated the reinforced roof and detonated among workbenches loaded with circuit boards, laptop computers, and programming equipment. The overpressure wave destroyed delicate electronics throughout the facility, while fragments shredded anything that survived the initial blast. The third GBU-39 impacted the storage warehouse at 153341. Intelligence. Estimates indicated 15 to 20 completed. Shad 136 drones were stored here awaiting deployment. Each drone carried 40 kilograms of explosives, creating a massive secondary explosion when the American weapon detonated among them. The combined blast destroyed not just the inventory, but the entire logistics chain supporting drone operations in the southern sector. Fuel supplies, spare parts, and maintenance equipment worth millions of rubles vaporized in seconds. The fourth weapon double-tapped what remained. The Krasuka-4 operators finally realized their jamming had failed when explosions rocked the target complex. Their system had performed exactly as designed, flooding GPS frequencies with interference that should have sent the weapons flying blindly into empty fields. They had no way of knowing the GBU-39s had been specifically engineered to counter Soviet-era electronic warfare systems that relied on brute force jamming. American engineers who had studied Russian capabilities for decades had built counters into every circuit. But now the MiG pilot had to get home, and the Russians were not about to let him. At 1534 local time, the pilot leveled off at 400 feet above ground level with 750 kilograms of fuel remaining. His tactical computer showed 180 kilometers to Ukrainian airspace, 12 minutes of flight time if he maintained optimal cruise settings. Behind him, secondary explosions sent smoke columns rising 3 feet as stored munitions and fuel supplies added their energy to the destruction. The radar warning. Receiver displayed multiple missile launches from SA-15. Batteries as they attempted to intercept him during egress. Their missiles accelerated to Mach 2.8 within seconds, but the pilot was one step ahead. At his current speed and altitude, terrain features would mask his position before the missiles could close within their 15-kilometer effective range. The river valley ahead provided a natural radar shield that would break their lock in 45 seconds. Russian air defense commanders vectored 2 Su-35 fighters from Berdyansk to intercept, but the geometry worked against them. The fighters needed 8 minutes to reach the MiG's current position, by which time he would be 75 kilometers closer to friendly airspace. Their R-77 missiles had excellent range, but acquiring a target flying at 400 feet through ground clutter exceeded their radar capabilities. The pilot maintained his flight path, knowing that climbing would only make him easier to track. At 1538, he crossed the Molokna River, running southwest toward the Azov Sea. This geographical feature marked the limit of effective Russian radar coverage due to terrain masking. The SA-15 batteries lost lock as he disappeared behind the ridgeline. Their missiles self-destructed harmlessly after losing guidance commands. The Su-35s continued their pursuit, but their fuel state would force them to abandon the chase before they could close the distance. Post-mission analysis revealed critical intelligence. The GBU-39s had maintained navigation accuracy within 12 meters despite continuous GPS jamming, validating American claims about the weapon's electronic warfare resistance. The Krasuka-4 system had performed exactly as advertised, but failed to defeat weapons designed with Russian capabilities in mind. Ukrainian innovation had transformed a 40-year-old aircraft into a precision strike platform, delivering modern effects through desperate creativity.